Hello everyone, my name is Jennifer Wells and I am the MnDOT Bridge Inspection Engineer for the state of Minnesota. Today I'm going to talk about enhancing bridge safety inspections with UAS. Presentation outcomes learn current and future drone technologies that we have been looking into that are effective for bridge inspection. Not all drones are made the same. How to successfully implement this technology into bridge safety inspections. Understanding the benefits and costs associated with that, and understanding drone data needs. Once we have the drone data, what do we do with that? So our program started in about 2015, middle of 2015. We started with a phased research. Since the technology was very new, we wanted to make sure that we had our ducks in a row, so to speak, to prove that this would be a beneficial tool for bridge inspection. We are currently in phase 4. Phase 3 was completed in the summer of 2018. The published report you can get at that URL link listed there. And right now we are in the final implementation phase with the Metro District. We did purchase an Helios drone. As you can see there, the caged drone in the middle of the screen. We are in the final phase of completing this project. We're just in review with the final report, which should be published within a couple of months from now. Also in 2018, a couple years ago, Federal Highway has an Everyday Counts grant for state transportation innovation. So we applied for this, which could be used for implementing a drone fleet. Basically, we were given a $100,000 grant, and we did a match of $25,000 in drone purchases. I am also on the Federal Highway EDC 5 Community Committee for Drones. I am their structure expert. We also have other state DOTs on the panel for experts in emergency response and also construction and surveying. We have also acquired since then a supercomputer and a super server to hold all of our drone data, so it is off our network servers. Our IT department decided about a couple years ago that this was coming, and we needed a place to store all of our drone data, so it was off of the other servers. And currently that server will be holding all drone data within the state. And I have specific folders set up just for bridge inspection. There are a lot of different entities around MnDOT that have that use drones, such as communications, photogrammetry. They have all of their own folders and access to this, to their data as well. We are also looking into digital twins or artificial intelligence in regards to 3D modeling with the drone data. So that's the next part. What do we do with all this data that we're getting? So currently we purchased 2 Microsoft HoloLens to utilize drone data in a 3D mode, being able to visually see this bridge, through these lenses and pinpoint defects, being able to show other entities, share information across different areas of MnDOT, such as load ratings, design, roadways, so that they can see what we see on a bridge. Also being able to show deficiencies and change over time on bridges, being able to add in notes, spotlight defects, and just create more of a living document of a bridge as a whole. So looking at assessment of UAS technology, we needed inspection-specific drones. When we started this back in 2015, there really wasn't anything ready on the market yet of a drone that could operate without GPS, because you obviously lose that signal when you go under the bridge, and it won't go under the bridge at that point. It'll return to its home base. We also needed cameras that had the ability to look up, that are object sensing, so we want to get as close to the bridge as possible without hitting it. Also having all of the bells and whistles, photo, video, and thermal imaging as well, because we are able to do thermal imaging comparisons with the thermal cameras on drones in regards to bridge deck delaminations. And we also wanted drones that could fly in confined space settings. Believe it or not, a lot of bridges can be hollow or have hollow elements to them. I've been in quite a few. So commercial drones, those are the more expensive ones, the $20,000 to $35,000 range, and that's because of the sensors and camera capabilities on these drones. There is a list right there showing some of the drones that we've used that are in that commercial drone range. We are actually purchasing a DJI Matrice, not the 210, but now the 300, the newer model. We should have that with us by spring. So the benefits of a large commercial drone, obviously you have reliability, durability, sensor size, a purpose built for inspection, but obviously they are very expensive. They are the best ones for doing 3D modeling or getting that great detail that you would need for a model. And then there are the consumer level drones. These are in the $500 to $2,000 range or a little bit more. So those are like the DJI Mavic, the Parrot, the Nafi, the Skydio. These are nice because they're low cost, they're small size, and they've really come a long way since 2015 in being able to fly manually without GPS. Cameras that look up, sense and avoid technologies. It's just the limiting factor is a little bit of the less sensor size, smaller cameras, things like that, but these are perfect for what are our bread and butter inspections, routine, regular inspections, everyday inspections, something that you don't need necessarily to have a 3D model on, although they are capable of producing these models. They're getting that good, but this is a lot easier. We can get a lot more drones at a consumer level grade that will give us the data that we need. This is actually a picture of me on our St. Croix bridge crossing. This is one of our snooper trucks. We have a fleet of 7 snoopers for MnDOT. I am over the bridge railing. This bridge is like 200 feet up in the air. I am tied off there. I'm mapping out cracks along these cable stays that are coming in. And this picture was taken by the drone that was flying way above me. I didn't even hear it, but it didn't even need to get close to me to get into the level of detail, as you can see here, just because of the zoom capabilities of the camera. So what are our goals in inspecting bridges? One, we need good planning, especially when the bridges are very large. Our purpose is to detect conditions and deficiencies in order to provide proper maintenance to bridges over time. Our big goal too is to document. We really need to, document what we're seeing so that future generations or people coming in can see what was documented in the past, so that you can see changes over time. And being able to communicate these findings with other entities in the DOT, such as load ratings, design, construction, roadways, anybody that may need this information in the future. Because not everybody's a bridge expert. Nobody's on bridges as much as I am, so being able to share 3D models and images showing exactly where problems are and give a good overview perspective really saves a lot of time and confusion when explaining these defects and conditions to other entities. Inspection planning with drones has been really a great feature for us, especially for a larger bridge, going out ahead of time, doing a flight plan, doing a 3D autonomous flight to fly the bridge, not directly over traffic, of course, but just to get ideas of where each of the cells or members are on a bridge, where are our meeting points in the morning, where are their bathrooms, because that's really important when you're on a bridge all day. Being able to detect defects and deficiencies. Drones are not to replace inspectors. We don't want that. We don't want to persuade or convince people that's what our plan is. We're simply using this as an additional tool to help us gain access, gain better data into places where typically cannot be accessed without a snooper. And you're not going to use a snooper on every bridge, of course, but you want to be able to get up to bearings and high wall abutments. But our traditional access tools are obviously aerial work platforms, rope access, ladders, binoculars, our snooper trucks, as you can see there on this bridge. Documenting the condition and deficiencies, again, we have reality modeling software. We're working with Pix4D and also Context Capture and Bentley, getting input of images, using ground control points to gain better accuracy, having multiple outputs available, orthomosaics, point clouds, 3D mesh, CAD, just regular photos or video. I mean, it's perfect. Everything that we possibly need to convey the findings that we're trying to show. Here's an example of a point cloud from the drone data that was obtained for this bridge. Here we can, after the post-processing, go in and actually measure and count out the deck tracking on here, which is super helpful, and all the individual pictures are in here. Then you can also label what you're looking at here, joints, joint filled with debris, adding inspection notes, things like that. This is our traditional reporting, basically pen and paper. We are moving towards more of a digital platform with tablets, being able to automate this as much as possible, and having drones to getting data for us is going to make that automation even more spectacular. So on this slide here, you can see there's a lot of little pinpoints here. So these are areas where the drone took photos or still photos when it was overlapping to get this point cloud made. And you can see on the right here, we can put in the name of what this particular dot is. It's maybe one of those over here. Labeling what the bottom chord is, what comprises of the bottom chord, and the note that's on there. We also have our GPS coordinates of where this member is within space. So the benefits that we found, obviously safety improvements for inspectors and the public. We were able to reduce the amount of work zone time by having a snooper truck in if we can use a drone to get the data that we need instead. And of course the public likes less traffic jams as well. We also get quality gains in the data. We're getting better data, better access, so that our inspection reports are more reflective of what's actually out in the field. Because we were finding that inspectors were not getting adequate access, and then when a bridge was coming up for a rebuild or maintenance, they used the inspection data, and of course that seemed to not work out as well, or it wasn't the same as what the bridge was in the field. So a contractor would be out there and said, you got a lot more problems here than you thought you did. So then you have scope creep and the price goes up. And this was happening so often it got the attention of upper management, and they're like, what is going on here? So that is an important thing, getting us access, better imaging, better data. And it's also a cost savings. To fly a bridge is relatively pretty fast. To set up a work zone with snooper trucks and traffic control and all of these other entities takes a lot of people. Of course, we're looking at a combination of the two, you know. Of course, fracture critical bridges, truss bridges, ones that could fail with one member being gone, those will always be hands-on with the inspector, but we can use drones to enhance our inspection as well on those, gaining the 3D models and being able to pinpoint the deficiencies. The challenges, of course, at first were learning curves. Especially in 2015, there was not a lot of great drones out there for inspection purposes at the time, and just all of the rules, knowing airspace rules, FAA rules, what will the public perception be? What about data privacy or privacy of others? Not being able to be hands-on, obviously. So if we have to do non-destructive testing methods, that's still part of what the inspectors do, until, of course, drones in the future can do that as well. And like I said, acceptance, rules and regulations, and at first data storage. Where are we putting this data? And at first we actually just held it on external hard drives. But luckily our IT department saw this coming and was prepared for it. We also did do a safety analysis in the beginning phases to show that we're reducing risk. Removing inspectors from harm's way in regards to heights, traffic, confined spaces. You're reducing traffic control, improved safety. I mean, for one, last year I was on the Blatnick Bridge in Duluth, Minnesota, and I was on a snooper truck underneath the bridge with a coworker of mine, and someone infringed on our work zone and actually hit our crash truck a little bit. So if you get hit, if you've ever been on a snooper underneath the bridge, if you get hit above, you're pretty much toast. So reducing those kinds of things will really help us in the long run. There's been hundreds of inspection flights with no incidences or close calls, and the data for work zone accidents is very clear and always published. So you can see on this slide here, you're overcoming that risk by using drones as much as possible. We also did a cost savings, and this slide will be updated more when we completed our phase 4. We looked at all kinds of different bridges, small, large, rural, urban, steel, concrete, culverts, to compare what traditional inspection cost would be as opposed to a UAS assisted inspection cost. And we were finding that we were getting an average of 40% savings. Most of the savings were where traffic control access and access equipment could be reduced or eliminated. There's also a time savings as well in the field. So that is all I have. If you have any questions, here's my contact information. I'll be glad to answer questions when we are allowed to do so after this event. So thank you very much.